So comparing the reduction power, this is actually experiment which can be used to compare the reduction power of these ions. So as we know, in terms of ions, we know reduction power of iodide ion is more than bromide. Bromide ion is greater than chloride, and chloride is better than fluoride. Practically, how we can show this that the iodide ion is a better reducing agent than bromine. Bromine is better than chlorine, and chlorine is better than fluorine. So the practical technique based on the using the observation we can work out. So it is very important that this is very important reaction. Unit 3, you will find almost every year the question is there related to these observations. So as we know, iodide ion is larger in size, it can lose electron easily, so it can help in by itself it is oxidized, which is a loss of electron, and help the other for to reduce. So if we add sulfuric acid and we have like a solution contain iodide ion, bromide ion, chloride ion, so we'll have different products. So the formation of different products can give us an idea that the tendency, the reduction power of these ions. For example, H2SO4. What can be the product if we have H2SO4, sulfuric acid? So sulfuric acid, each oxygen is -2, so 4 oxygen will be -8. Each hydrogen is +1, so 2. Each hydrogen +1, so 2 will be +2. So sulfur should be +6. So in sulfuric acid, the sulfur oxidation number is +6. Then what are the possibilities? What might happen whenever sulfur react with the substance? We can have different products can be given off when sulfur is reacting, when sulfuric acid is reacting. So when sulfuric acid is reacting, we might have sulfur dioxide might form. That is one possibility. So if sulfur dioxide is formed, what will be the oxidation number? Each oxygen is -2, so 2 oxygen will be -4. So sulfur will be +4. So sulfur might reduce to by 2, the oxidation number, and it changes from +6 to +4. Then what is the second oxidation number? Change. It can form another product, so it might form sulfur only. So if it forms sulfur only, then what will be the result? The oxidation number changes from +6 to 0. Or it might form hydrogen sulfide. So if it might form hydrogen sulfide, so each hydrogen is +1, 2 will be +2, so sulfur will be -2. So when we compare these products, like example, if we have sulfuric acid and sulfuric acid turn into form a sulfur dioxide. So what is the oxidation number change? It is changed from +4 to +6 to +4. But if a sulfuric acid react and it forms sulfur as a product, so it means it changes from +6 to 0. And we have sulfuric acid H2SO4 and it forms hydrogen sulfide H2S, so it will change from +6 to -2. So which one is a lower oxidation number, like greater change in oxidation number? The last one, when sulfuric acid form hydrogen sulfide gas, that's a bigger change in oxidation number as compared to when sulfuric acid forms sulfur dioxide or sulfur. So what is the product we expect? Because we are saying iodide ion is a better or a good reducing agent, so iodide ion should reduce sulfur to very low oxidation state, and as a result we should get hydrogen sulfide. The observation, you should know the observation for this. Like example, if for a reaction sulfur dioxide gas is given off, so that is a pungent gas. If sulfur is there, so you can mention a yellow solid or a solution will turn cloudy. And if hydrogen sulfide gas is there, that is having a smell of a rotten egg smell. When the egg rotten, actually it is emitting out hydrogen sulfide gas. That's smell of hydrogen sulfide, or we can also say it will have a smell similar to that of rotten egg. So these are the observations depending on which ion is added, like we add chloride ion, bromide ion, or iodide ion. If we add chloride ion, there will be a change in. If we add a chloride ion, there will be a change in oxidation number, but there will be a lower change in oxidation number compared to bromide or iodide. So example, this was the intro of the topic. Now example, if we are reacting fluoride ion and chloride ion with sulfuric acid. So first what happened? We have sodium fluoride, or we have sodium chloride, and we add sulfuric acid. So the moment, like here, sodium fluoride, fluorine is -1, and sodium chloride, chlorine is -1. So when it reacts with sulfuric acid, it forms sodium hydrogen sulfate and hydrogen fluoride. What is this reaction? As you can see, there is no change in oxidation number. How there is no change in oxidation number? You can see sulfur is +6 here, and each sodium is +1, each oxygen is -2, so 4 oxygen will be -8. Hydrogen is +1, so sulfur should be +6 because the overall compound is neutral. So before it is +6 and after also +6, so there is no change in oxidation number of sulfur. That is why we don't say this is a redox reaction. We only say it is an acid-base reaction in which sulfuric H2SO4 is donating proton, acids are proton donor, and bases are proton acceptor. So H2SO4 is donating proton and NaF is accepting proton. That's why we call this as acid-base reaction. But this is not a redox reaction. And whenever you get hydrogen fluoride, when HF is there, or HCl is there, or HBr is there, or HI is there, these all are misty fumes. Or whenever these gases are given off, what will be the observation? It will always be a misty fume. So same thing happened if we have sodium chloride, we add sulfuric acid. Again, there is no change in oxidation number. If there is no change in oxidation number, it means this is not a redox reaction. It is only acid-base reaction in which one is donating proton, another one is accepting proton. Is it clear? The first part. So with fluoride or chloride, it is not a redox reaction. It is just an acid-base reaction because fluoride ion or chloride ion are not able to convert the sulfur which is present in a sulfuric acid from +6 to any lower oxidation number because they are weak reducing agent. So there is no change in oxidation number for sulfur. So H2SO4 turn into NaHSO4. So as a result, the sulfur oxidation number remain +6. So no change. That's why we say they are not a good reducing agent. So what will the observation? Observation will be a misty fumes because of formation of hydrogen fluoride or hydrogen chloride. But if we had a bromide ion, then what happened? First thing what happened? Sodium bromide, like example, the previous one was sodium chloride and sodium fluoride, but now we are taking sodium bromide. So first one is an acid-base reaction. Sodium bromide reacted with sulfuric acid gives sodium hydrogen sulfate and HBr. When HBr is there, we'll observe a misty fumes. Then this HBr reacted with H2SO4. So this HBr, hydrogen bromide, in which bromine is also -1, reacted with H2SO4. So this is a redox reaction in which it form a bromine molecule. So when it form a bromine molecule, we'll observe brown vapors or fumes, and it forms sulfur dioxide. So pungent gas will be there, and water. So you can clearly see like bromine is -1 turned into 0. If -1 turned into 0, so this is oxidation. Or bromide ion is acting like a reducing agent. But for sulfur it is +6, and here sulfur is +4. So +6 change to +4, it means that is a reduction, or it is by itself it is oxidizing agent, but this change is a reduction. So +6 change to +4, And this observation of pungent gas, a sulfur dioxide gas, is responsible for showing a result that this is reduced, like sulfur plus 6 has reduced to plus 4. So sulfuric acid is playing a vital role for first step because it produces hydrogen bromide, and then act as an that hydrogen bromide then act as an oxidizing agent in the second step. So first step, sulfuric acid produce hydrogen bromide, and the product hydrogen bromide further react with sulfuric acid to give bromine, sulfur dioxide and water. Is it clear? The reaction with bromide. If we have iodide, then multiple possibilities are there because iodine is better reducing agent than any other halides. So we'll have multiple products because possibilities are there. First one is when sodium iodide react with sulfuric acid. This is acid-base reaction. So it will produce sodium hydrogen sulfate plus hydrogen iodide. This hydrogen iodide react with sulfuric acid. So what are the possibilities? As we know, iodine is better reducing agent. So what might result? It might produce iodine molecule and sulfur dioxide, or it might produce iodine molecule and sulfur, or it might produce iodine molecule and hydrogen sulfide. So if it produces sulfur dioxide, oxidation number will be +4, sulfur it will be 0, and hydrogen sulfide it will be -2. So that's why multiple possibilities are there. If like two molecules of hydrogen iodide are there, then iodine molecule sulfur dioxide. 8 molecules, then sulfur will be there, and sorry, 6 molecules sulfur and 8 molecules it will be hydrogen sulfide. And what are the observation? The observation, because if iodine molecule is there, iodine solid is there, so that's why there's a black solid. Sulfur dioxide is there, the acidic or a pungent gas. Sulfur is there, a yellow solid. Hydrogen sulfide is there, a rotten egg or a bad egg smell. So, and it is easy to write a product. Is it like sometimes they say write equation for reaction when sulfur is formed or sulfur dioxide is formed. So it is very easy to write this equation as we have already discussed in a redox reaction, that example, if they say write a equation for reaction between iodine and sulfuric acid for if it form say sulfur dioxide. So sulfuric acid, we want to form sulfur dioxide, and it is reacting with iodine to form iodine molecule. First we will balance this equation. We have 4 oxygen on the left hand side and 2 oxygen on the right hand side. So in a redox equation, if we want to balance oxygen, we add water. So we add 2 water molecule. Then to balance hydrogen, we add protons. So 2 are already 2 multiplied by 2, 4. So 2 are there, we add 2 proton. Why I did not write any number here? Because if I write number here 2, it will balance hydrogen, but again it will unbalance the oxygen. So it won't be correct. Then we balance other elements, so sulfur is already balanced. Then we balance the charge. So +2 here, neutral, neutral, neutral. So we should have 2 electrons. So this equation is balanced in terms of electron, in terms of charges, oxygen, hydrogen and other element. And what was a reactant? Iodine was there. It was forming iodine molecule by loss of 2 electrons. So when we want to combine the equation, what we do? We take the number of electrons same, but they already have the same number of electron. So when we add, it will be 2 protons plus H2SO4 plus 2 iodine gives sulfur dioxide plus 2 water molecule plus iodine molecule. So this is how we write the equation. So you can write it for any. Like example, you don't have to memorize this equation. Within 2 minutes, you can form an equation depending on what will be the product. Is it clear? The two equations, how we can write a balanced redox equation? So if you want to test the halide, like which halide is present, so that we already discussed in IGCSE. If we want to test a chloride ion, we can add silver nitrate or lead nitrate. With iodide ion, it will give yellow precipitate. With bromide, it will give cream precipitate. And iod chloride, it will give white precipitate. If we leave these precipitate in sunlight, so it will turn to be gray or black, or it darken because of formation of the sodium metal. Like example, in this sodium iodide, sodium metal is formed. That's why it will turn to be. So the precipitate except silver iodide darken in sunlight, and this reaction is used in photography. Like example, if we have silver chloride, it turn into silver atom and chlorine molecule in the presence of ultraviolet light. So if the precipitate are left, they turn or they darken. You have to learn this. An effect of ammonia solution. So what is the effect of ammonia solution? This is just because it is very difficult to recognize the type of halide ion. Like example, we have silver chloride, which is white PPT. We have silver bromide, which is cream color precipitate. So there are approximately like the similar shades are there. So it is difficult to recognize which one is there. So we can carry out a confirmation test, or we can say CT. C stands for confirmation and T is for test. So we can add aqueous ammonia, and aqueous ammonia can be dilute or concentrated. So if we add ammonia solution or aqueous ammonia in dilute or concentrated, this will dissolve, soluble. But silver bromide is only soluble in concentrated, and silver iodide is insoluble, does not dissolve. So using this aqueous ammonia test, we can identify. You don't have to learn these equation. This is in A2. It's equation for known as a complex equation. You just have to remember or memorize the observation that if we add dilute or concentrated ammonia solution, the precipitate will dissolve for both silver chloride, and in concentrated only silver bromide will dissolve, and silver iodide remain insoluble, does not dissolve. So this is the confirmation test, or CT, for this reaction. Then how we can produce hydrogen halides? We can react them with acid, like we can also react them with sulfuric acid. So sodium chloride or phosphoric acid. So sodium hydrogen phosphate plus HCl, and as a result it will produce a misty fume. Same way, so phosphoric acid is not an oxidizing agent. Why we are using a phosphoric acid here? Why not sulfuric acid? Because if sulfuric acid is used, the first it will act like an acid base reaction, and next it will act like an oxidizing agent. That's why if we want to limit and we want to stop till hydrogen chloride or hydrogen bromide or hydrogen iodide, in that case we should prefer to use a phosphoric acid. Then solubility of these halides in water. The hydrogen halides are very soluble in water, and they dissolve to form an acidic solution. And all hydrogen halides react readily with ammonia and give a dense white smoke. Because ammonia with HCl, ammonia with HBr, ammonia with hydrogen iodide, it will produce ammonium chloride, bromide, or iodide, which is a dense white smoke. So to test these hydrogen halides, we can use this ammonia solution. So why sometimes they ask, like if you want to produce hydrogen chloride, why we are not using sulfuric acid? So what is the reason? Or if you want to produce the example hydrogen bromide, why we are not using a sulfuric acid with sodium bromide? Because sulfuric acid is an oxidizing agent. It can also oxidize that hydrogen iodide, like iodide or bromide to bromine molecule. It does not produce that molecule again. It can ion again. It can oxidize them as well. Is it clear, the solubility and the testing for these ions? So this was about the topic group 2 and 7. The next session we will discuss the topic wise question. Any question related to the class today? Any question or a doubt?